Welcome to the second episode of the land development series. My name is Griffin Furlong, and in today's video, we are going to analyze existing topography. We're going to be delineating basins, and we're going to be thinking about how we're going to set up an existing conditions drainage model. If you're a young, aspiring land development engineer, you may want to watch the previous episode where we learned how to read geotech reports, traffic reports, surveys, and the various other documents that we get when we start a project. But I'm ready to go, so let's dive right into it. Now, I know everyone is anxious to dive into the technical, but the important thing about this land development series is that this helps build all-around great civil engineers. That means that my small lectures about the big picture of why should not be skipped. Now that I have your attention, the first thing that I'll say here is that the existing conditions drainage analysis is extremely critical to your project. This is where you can miss on millions of dollars in cost and in time. Why? Well, let's say you overlook an existing ditch that's carrying 300 cubic feet per second of flow through the middle of your site. No worries, you'll just cut it off, right? And you'll build a berm around your site. Well, no, because the water has to go somewhere. And since it's a high discharge, you may have missed a big cost of installing large culverts, head walls, and potentially even a bridge. Typically with your land development site projects, drainage will dictate everything because drainage typically dictates the earthwork of your project. And if you haven't learned by now, earthwork is one of the largest costs in a land development project, and second to that could be drainage. Now, before diving in here specifically to the topo that we received from the surveyor, I want to just kind of walk over a few things that we're going to be looking for. Now, there's definitely more than just a ditch to worry about, right? So what are some of the other things that we're looking for? Some of the other things that we could be looking for are large depressional areas, and this could be a wetland, this could be a pond, or just a pool of water, or perhaps it might not even be full of water. It might be dry in a normal condition, and there might be a big depression. So why is this important? Well, when you see these large depressional areas, they might have some floodplain associated to it, because if you think about it, it is a volume that can hold a certain amount of water. So we need to know if this water ever discharges or if it just fills up. Other things that we're looking for are any sort of on-site culverts or weirs. So typically the surveyor will pick those up. If you were a part of the very last video, you notice that we didn't pick up any existing infrastructure like that. Other things we're looking for are the lowest points of elevation and areas of high and low elevation. Now again, we are going to be diving into this topo, and automatically I see a huge ridge right in the middle of this property here. And a lot of this water, once it hits, it will go somewhere. We'll dive into the specifics, but these are the things that I'm looking for. And in this video, I'm also going to show you how you can use AutoCAD to help you understand the existing topography. We can walk through the different CAD styles in order to help us identify the highs and lows. Other questions that land development engineers are typically asking is, what is the tailwater? What's the tailwater condition of the site? Are we going to be discharging into some body of water that has a water level already associated to it? Well, the tailwater is very important because that is what we're discharging against. If you didn't have some sort of tailwater, then it would be more so of a free flow condition where you are just discharging your waters into a free flow state with no tailwater or back pressure that's trying to push against the tailwater, if that makes sense. Other things that we're looking for are pop-off elevations. So typically when you have some sort of wetland on site or depressional area, there might be what's called a pop-off elevation. Think of the pop-off elevation as the lowest elevation at which water can start discharging. Now, once we examine this wetland, we might be able to identify the pop-off elevation. Now, obviously, we look for a large list of things, but I think one of the most important things too is the type of land cover of this project. Land cover impacts the discharge rate because some land covers have more pervious area or permeable area, which allows water to soak into the ground, therefore lowering your discharge rate. Impervious land cover on the opposite side is less permeable, Therefore, water doesn't soak in the ground. An impervious area is anything like pavement, curbs, building, sidewalk. Now, this will become way more important when we're developing our CN or curve number calculations, which won't be in this video. Again, all right, with that, I think we're well on our way to really dive into this beast. So I think it is very important to know your on-site versus your off-site basins. Think of it as we are responsible for controlling our own waters on our own lands that we own and managing the basins of other lands that flow through our site. So let's say again, if we had some sort of huge ditch running through our site, which I already know now we have no sort of thing like that, but let's say if we had a huge ditch rolling through our site, we would need to know exactly how much CFS that is, or flow, and pending how much flow, we would need to design accordingly. Now, how are we going to establish our on-site and off-site basins? Well, that first thing you're going to need is your property boundary. So I'm going to go to this existing base here, and I'm actually just going to grab this line. So this blue line is our property boundary. I'm going to do a clipboard copy. Some people use copy 00, but little do people know that you can just do that by doing paste to original coordinates. So here we have our official property boundary, right? And looks like we got a few points and contours outside to help us understand if we're capturing any offsite flow. So that's going to be my first step. Another way that you can just get your basin here is you can do a simple XREF. Another thing that we can do is just XREF in that existing base that we have and control the layers and only show the property boundary and other various features. So let's do that. So here we're going to select a reference. So once I say I want to reference another external reference, I'm going to reference this existing base drawing. And when you XREF this type of stuff in, just notice your layer. I am on an XREF layer, so whatever layer you're on, that XREF is going to be on that layer when you pull it in. And I can actually prove that to you because if I select this guy right here, it's on an XREF. So that's showing me that it is an external reference I'm referencing in this drawing, but I notice up here that it is on the XREF layer. I think one of the first things that I want to do here is just start by annotating the surface because I really want to know the existing contour elevations, and the only way that I can start doing that is actually labeling these with some dynamic labels. So in order to do that, you can go to the annotate, you can go to surface, and we're going to go here, let's do contour multiple. So let's select that, and it's going to ask if we want to specify the first point, and then it's going to ask us if we want to select the second point. So here I'm noticing this ridge, so I'm going to start here at the very tip top, and I'm going to go all the way down here and label these contours. And notice how, I don't really like this style, but notice how all of those contours were labeled. We got 53, 52, 51, 50, 49. So this is, in fact, traveling downhill there. So that's going to be one important feature when we start delineating this basin is there's this huge ridge which is controlling all of this water here that's going to this wetland. That's the first thing that I'm noticing. So I can already tell that our basin is really going to cut off here at some sort of point. Now you can always change these contour labels to make them larger or just make them different. So let's show you that. We can go to properties here and we can go to the properties dialog box, surface contour label style major. So we're labeling the major contours, which is just your larger increment. So in order to actually revise this, we can go to surface contour label style major, and if you just click this button, we can do edit current selection. So here we can actually edit all of the information that we want, right? So we can even change the height because it's reading kind of small. So I'm going to go ahead and change the height. I want these guys kind of big. I don't really know how big yet. So I guess we'll see there first. Let's just see what that does. Let's see if that helps us. All right, perfect. Yeah, that helps out a lot. So, way bigger so we can actually see it. So I'm going to start labeling some of these contours. And if you don't like this line here, You don't have to show it, so you can go here right to this property display contour label line. I don't want to see that line, guys. It's just kind of ugly and it's distracting. So you can do that by going to properties. So I'm just going to go ahead and label some of these contours. That way we know exactly what we're dealing with. Also, another tip is that every time you do a command, you can always press enter or the spacebar and it will repeat that same command. So this becomes really handy when you're doing tedious work. So I definitely use that one often. Another thing too is that you can select similar. So again, I created all of these lines. I'm gonna go ahead and just press select similar. Go to my properties, display contour label line, and I am just going to do false. And then it wipes it all away. All right, so I've labeled everything that I've wanted to, at least so far. I am gonna slap on a few more labels, but I wanted to walk through what I'm already noticing about the site. Let's take a look at this giant wetland. This is gonna be the main topic of discussion, guys. This is a very large wetland right in the middle of the site. And I'm noticing that there's going to be a lot of water discharging to this wetland. Reason being is because I've already pointed out this very large ridge here. But notice that this ridge is also almost just like a bowl. Everything around this wetland is pretty much dropping in elevation. And a couple points I want to notice here is notice how we're at elevation about 50, 51. So we're anywhere between the 50s and 40s, right? All of this water, once water drops, all of this water wants to travel down to this wetland. And even same over here. Look at the left side or the west side of the wetland. We're at elevation 44, 43, 42. So again, water wants to move to this wetland. And that's all we are going to be doing, guys. In this video, we're going to be analyzing where water wants to go. We're going to act like we're a water droplet, and we're going to delineate the basins based off of our analysis. Let's take a look at this top. So it looks like this water up here does not want to drain to this wetland. We have some sort of high point right here because I'm looking at this elevation of 45 here. And if I'm a water droplet, well, where do I want to go? Naturally, it looks like water wants to fall downhill over to this, I think it's a floodplain compensation area. We can look back at that survey and see what kind of information that we got on this guy. Another important thing too is that we have these existing ponds. So we have existing ponds here on the west side of our property, but it doesn't look like any of this water actually wants to go into this pond just based off of the topography that we see. All of this water wants to travel east to this wetland. Now, if you're having a really tough time seeing this, what we can do is that we can look at some potential AutoCAD surface styles to help us analyze this topography. Again, I've been doing this for about 5 to 6 years now, so I'm able to quickly pick up on where water is going to be flowing. But let's say if you are having trouble, one really cool thing about AutoCAD Civil 3D is that you can control the styles. So let's say if you really didn't love looking at all of these contours, we can go here to Tool Space. Tool Space is basically where all of your smart information is going to be reading from or just live. So again, you have surfaces here, you have points, you have pipe networks. This is where all of your dynamic smart objects will live. So here, since we have existing grade, which is all of these yellow contours here, I want to start playing around with some styles. In order to do that, you can right click. And the first thing I want to do is go to surface properties. I actually just want to see what surface style it's using. So surface styles here, we have contours, and it looks like we have some other ones in here. Again, depending on your company or if you're just a solo designer, you might have some different surface styles in here. These are the surface styles that I have in my sandbox, but again, we can always create these. So let's actually walk through a couple of different ones that I have. It doesn't really look like I have any ones that would be of use. I can show you this points and triangles, Points and triangles is cool. Points and triangles are good when you're trying to clean up your surface. If you have any sort of weird spots like zero elevation spots where it's causing huge holes in your data. I have a whole video about some of the different AutoCAD surface styles. Points and triangles is ones that I will not be using for my watershed analysis. So with that, I'm going to go back to contours and I'm going to copy this current selection, and we're just going to go ahead and make a new style, guys. And what I want to call this is, you can call it whatever you want, but I'm going to call it watershed analysis. And the first place that I'm going to go is display, because display is actually going to show what you want to see. So what do we want to see? Well, I still want to see those major and minor contours. I'm pretty good with that. But what else do we want to see? I want to see elevations. Elevation style in CAD is ways that we can show a colorful diagram of where the highs and lows are. So I'm going to go ahead and click that one. Now you do have these other ones in here like slopes. I like slope arrows. We can do slope arrows. It'll show you all of the slope arrows of where water wants to travel. Watersheds is a good one, but I'm going to put that one on hold for now. Now since I have the data that I want to see when I display my surface, now it's time to actually input the data that I want to see. So I'm going to go ahead and press OK. We've made our style, and I'm going to go ahead and press apply just to see what we're cooking with. Now, we could totally leave this style the way it is right now if it makes sense to you. It looks like the brighter blue is where our lower spots are and the darker blue is where our higher spots are. But I don't think this is very intuitive, so in order to change how this looks, you can go right back into surface properties, and I'm going to go to the analysis tab. Here we have the analysis tab here, and our analysis type is elevations. That's where I want to be right now. Now I kind of want to walk through how I would set up these different ranges. So you can do a range interval, and I'm going to actually do a range interval, and I want to range it by 1 foot contours. I really want to see all of these different ridges and the differences in elevation. So I'm going to use a range interval of just 1 foot. So this will make it a little bit more defined when you can really see those peaks and valleys. Now, one thing I kind of skipped over is I actually need to go back to this watershed analysis, and I want to go here to analysis tab of the surface style of our watershed analysis that we created. I'm going to do this drop down for elevations, and this is how we can change the color of the surface. I don't really like dealing with blues. One that I really love is using land. Land is more intuitive, and I'll show you why. So I'm going to go ahead and hit apply, and I'm going to go back to this analysis tab, and I have to go back and actually hit this arrow again to make it all of the colors that I want. And I'll show you why that this is a little bit more intuitive. It's more intuitive, at least for me, because I think it's easier using a differentiation of colors, because it'll help you quickly identify the highs and lows. So you can clearly see the high point of the site, the intermediate points of the site, and the very lowest depths of our site here. This is a really, really good surface style to use when you are analyzing a watershed model. All right, so at this point, we have gone through AutoCAD and the different styles that we can use. We've labeled our contours, we've looked at the different surface styles to help us analyze the highs and lows of the site, but now it's time to actually use this data and start developing our existing basins. One little AutoCAD trick that I want to show you is if you want to make your polylines fat, you can start by doing the P-line command, and you can start your point, and notice how it's already kind of fat, but in order for you to change that global thickness, you have some options down here, and you can actually type in W for width, and you can give this a starting width. You can even go all the way up to 20 if you want, and then that makes that line thicker. Now if you type in width again, if you go all the way down to 0, notice how we're back to the very thin line. And the reason why I want to use thick lines here is because I really want to take a high level approach. I'm going to be drawing in these basins from almost a bird's eye view. So I want to be able to actually see the polyline. Another nifty command that I like is zoom extent. So if you type in Z, you can zoom, and then you can do E for extent, and that just zooms you out to the very extent of your drawing file. Really handy when you're zoomed in. The very first place that I really want to start is this ridge here. Notice this ridge, and I'm actually going to turn my snaps off because it's going to start clicking to each little point here. So you can toggle F3 to turn your snaps off, or you can go over here to this bar here and turn off your snaps. That way AutoCAD isn't going to be snapping everywhere. So I kind of want to start our focus on this ridge. We've talked about this ridge numerous times here, and what I'm noticing is that there is a huge break line here where if water falls on any of these sides, it's going to either go west or east. So that's kind of where I just want to start this high level basin break. And again, I'm not really taking a rocket science approach here, guys. I'm kind of eyeballing it here, but I am going to follow perpendicular to these contour lines. So when we get to this point, I can tell that it is the very highest point. This is elevation 53. And I'm going to keep going across this ridge here. I'm going to try to do my best to go perpendicular to the contour lines. Zoom in. So again, it's very important that you take a perpendicular approach because that is the way that water wants to travel here. It's not going to be moving sideways. It's going to go perpendicular to these lines. And notice here that I'm arriving at the property boundary. Well, it's really important that we're understanding where our property boundary is, because right now we're simply just developing the on-site basins. So I'm going to go here to nearest, and I'm going to snap right to that property line. So here we have it. We've developed, the basin ridge line here across this big ridge. And again, this is a partition between where water wants to flow. If this little hand over here is to the left of this line, all of this water wants to flow to this wetland. To the right of this line, all of this water wants to flow to this pond. Now, the reason why I bring up this pond is because now I want to start understanding how much area actually flows into this pond. So if I'm looking at it here, if I'm a water droplet and my hand's right here and travels perpendicular down this course, if I'm a water droplet, this water droplet makes its way basically right here to this wetland and doesn't go into this pond. So I'm trying to develop the best approximation for this basin line. But I think a line right here is pretty dang close. So again, I'm going to be going perpendicular. I'll do my best to go perpendicular. And then I'm going to go up to this range point. And it's important that we turn back our snaps. And I'm going to go right to that point. It's really good. I think a really important thing about this is that you want to make sure your snaps are on when you're touching the basins or the property line, because at the end of this exercise, we are going to want all of the basins to be closed basins. And I'll explain what that means once we get to that level. Now, one thing I forgot to do was close this basin here towards the property line. So I'm going to teach you a nifty command called the extend command. And it's going to ask me what polylines I want to extend. I'm going to extend that basin, and then this polyline here, and then now if I hover over this polyline, you'll see that it wants to, in fact, extend to the property boundary. Perfect. Now, of course, I have to keep making disclaimers, guys, because if there are very experienced hydrologists or any experts or professionals, obviously I'm taking a very high-level approach to this basin study. There can be situations where you already have a watershed analysis done by a municipality or a different company, and they've already taken the time to develop the basins, the nodes, the links, all that fun stuff. In that case, you have a project where you already have a developed watershed, and really at that point, it's up to you, the civil engineer, to just verify that those basins that were developed make sense to your specific site topography that you received from your surveyor. Because some of these watershed models, guys, can be very high level, developed on LiDAR and just the best available information. There's nothing better than getting really specific site survey information. Okay, so we've definitely have partitioned off some of these basins, right? And again, a basin is the area in which water is going to drain. Any water droplet that falls within this area is going to go to some sort of point of reference or a node, a storage unit, or it could perhaps be sheet flow into a particular area. So in this case, we've delineated this basin where water is flowing into this pond. So we've developed this on-site portion of basin that flows into this pond. Now let's look into this upper right quadrant here. If I'm a water droplet and I keep falling, it looks like all of this is going to this wetland. But I want to pay a little bit of attention to the different types of line work that we have. So on this eastern portion, we have a wetland. That was picked up by the surveyor. So if you go back to that original video of the survey, we know that this is a wetland, and this up here is actually an existing floodplain mitigation pond. So I think, when you run into this situation, I think it's best to kind of isolate the basins, because I want to know exactly how much water goes to this wetland and how much water would go to this floodplain mitigation pond. So perhaps my initial pass of this line could potentially change depending on how I'm trying to analyze this existing conditions map. Think of each of these as a storage unit. This wetland is a storage unit. We want to know how much water is going to the wetland, and this floodplain mitigation pond is a storage unit. What is the quantity of water flowing to these storage units? So if I take that kind of approach, now I need to start thinking about where the break is between these points and which water flows to this wetland and the floodplain mitigation. And I can already kind of see it. I'm seeing a point roughly at the corner of this property line, right? Because if I'm a water droplet starting right here and I flow perpendicular, it looks like I'm going right into this mitigation pond. But the question is, at what point does this water actually go into the wetland? So what I like to do is just kind of keep drawing these little streams and acting like I'm a water droplet. So if I keep going perpendicular at this point, and this point, water kind of wants to break right here and sheet flow into that wetland. So I'm going to draw another polyline just to kind of see and map this out. Maybe we can arrive to a particular point here. Also, we put on a pretty cool style that shows the flow arrows, so sometimes that can even help us out. But I wouldn't always rely too much on those arrows, because sometimes those can get pretty wild. There's almost just a point right here. There's a small ridge where these contour labels are, where pretty much any water on this side looks like it wants to flow to that wetland. So I'm picking up on that, and to me, it kind of feels something like this. Here, I'm going to turn those snaps off. To me, it feels something like this. Now again, I want to go perpendicular. And then I want to snap to the nearest property line. Now, I don't think that's perfect, guys, but again, this is really just an approximation on the best available data that we have. I think any stormwater over here wants to go towards this wetland, and then any drop of water here wants to head to the floodplain mitigation pond. Now, it makes me question why I even drew this line. I drew this line because I was just following the ridge, but if we follow the same approach that we did on this side and just add it to over here, well, then we can really understand this on-site basin that flows to this floodplain unit up here. Because if you remember, we have a wetland right here. So we have a couple of different nodes that we're dealing with. We have this wetland node, this floodplain mitigation node, and then this other wetland node. So I'm actually going to do the same exercise that we did here, just over here. So I'm going to hit the nearest. And again, I'm going to act like a water droplet. I kind of want to go on that same spot. I'm going to start right at that endpoint, turn my snaps off, and I'm going to act like a water droplet and try to find my way not perfect, but pretty good approximation here. So what I'm going to do is I'm going to trim these lines, and you can do that by typing TR. And I'm just going to go ahead and trim this line here. Don't trim the surface now. So I've trimmed that line because now we have a good ballpark of, the water that flows into this wetland, the water that approximately gets into that floodplain mitigation pond, the basin area that goes into this pond. And now we're going to focus on this wetland. I feel like we've delineated something good here to understand how much water flows into this wetland. And do you all see this little ridge here? I feel like there's just a little ridge right there where water wants to discharge to this open area. So I'm going to take that line right there and just work back perpendicular, and we will see where we end up. And sometimes this takes an iterative approach, and sometimes it takes, a second pair of eyes to actually, visualize where the water's flowing. This one's kind of tough because this is just a corner wedge right here, and we don't have a lot of great data right here to actually make this decision. One route that we could go is we could probably mess with the style again. I guess I'll do that. Let's go to this style up here and let's see what we can do. So we can go up to the surface style and let's edit so you can go to contour intervals. And right now the major interval is 5 and the minor is 1. We can kind of get crazy here. Let's do 0.25 and then have this at 0.5. And maybe it'll be a little bit more defined. So do you see that, guys? So we actually have some pretty good data here. Okay, that actually really helps us out a lot. So do you see how you can change the different styles of the surface to give you a better direction on these basins? And I'm even noticing it here. We probably could have taken a better direction right here because there's a little ridge, there's a corner. If I'm a water droplet and I fall right here, I actually do want to fall to the west. So that was a false line that I drew. But it's a good learning lesson. So let's go ahead and add, that little break. And perhaps I move this guy over a little bit more over here. All right, perfect. So, okay. Yeah, I'm glad I showed you guys that little tool. That way we can analyze this data a little better. So do you remember where we were, where we didn't have a lot of contour intervals from this 45 contour to 44, but now we have a pretty well-defined route here. So I'm going to continue, and I'm going to keep going perpendicular. Here's the thing, and what I might do here is I either might cut it across here, because again, it's kind of like a ridge, and then I think I might stop right here. And the reason why I want to stop right there is because any droplet of water that falls here wants to go this way. Any droplet of water here wants to go that way. And that's all we're doing with this watershed analysis. Always kind of move your mouse around or move your hand around if you got a big PDF opened up, and just follow where water wants to go. We're almost done. We're at 46 contour. I'm following my hand all the way down to this wetland. So we're almost good. I think this might be the last one here. I'm seeing a ridge. I'm seeing this as a high point. Maybe if I were to label more of these contours. So let's go to add labels. Let's add contour multiple. And it's going to ask to select your first point. and I'm gonna go ahead and do some of those. Okay, so that's an elevation 46 and it's dropping down to 45.5. So I want to get out this polyline tool. I'm going to start about right there. And I'm going to just keep doing the same exercise that we've been doing. So now I'm separating the water all from this area that's going into this unit, and then separating the water that's going north up here to this floodplain mitigation pond. All of this water within this property boundary wants to go there. And guys, we've pretty much have delineated all of the on-site basins. Now, typically what I would do as well is if I had more watershed data or LiDAR information on all of the off-site portions, I would go ahead and really start understanding this off-site portion. But due to just this video and how long it already is, we won't really be diving into that. We're going to take a very strong emphasis on analyzing what's happening on site here and developing the discharge rates. And as we've talked about really early on in this video and even in the last video, this is a project where we don't have offsite flows going into our project because we have a very high point here, and when water falls anywhere on site, it's pretty much just going to this wetland, this pond, or this wetland over here. So we don't have any major conveyances, any major channels, or anything coming through our site. Now, I would say one of the very last things that I do when I develop these basins is I definitely want to make sure that all of my lines are closed, and I'll show you what that means. So I'm going to go ahead and do the isolate command and only isolate our property boundary and our basins. In order to do that, you can do a command, or I just go simply up here to isolate. And what this does is it doesn't delete any lines or anything, but it just isolates the objects and the layers that you want to see. So it's basically isolating just these layers. So if I do zoom extents again, like I showed you earlier, here are our basins. These are all of the on-site basins here. Now there's a couple ways to actually close these basins. There's multiple different commands. You can do parcels, you can do the boundary command, or you can simply just do hatches. So I'm going to show you. If you type in hatch, it'll ask you if you want to select an object or if you want to pick an internal point. In this case, I'm going to pick an internal point, so I'm going to hit K, enter. And I'm just going to start developing some hatches here. And you know, if it hatches, that you do in fact have a closed boundary there. It'll give you an error if you didn't. See, so that one might not actually have. You see how it kind of gave me an error, guys? This is exactly why I wanted to show you this, because we must not have some sort of closed boundary here. So here's one thing that you can do. You can select similar, and you can right click and do generate boundary. And you can keep the hatches if you want, but I'm just going to erase, and I'm just going to show you kind of what that did here. So essentially what that did is you just created some internal boundaries right here. And what I would always do is open up a spreadsheet and start making sure and documenting each of your existing basins, because at the end of the day you want to make sure that all of these basins are closed and that you don't have any more on-site basin than your actual property boundary, because that wouldn't make sense. We've used the property boundary as the overall boundary of the project, so we shouldn't expect to see any more basin area or any less. But I'm really curious about what happened over here because I wasn't able to do a hatch. Okay, but I guess I am now. Sometimes CAD is weird. Sometimes there's no explanation, guys. That's the beauty of CAD. Sometimes there's just not a good explanation. There's just weird little band-aids and temporary solutions here. So I would consider this more so the easy method of creating the boundaries of your basins. I actually really love using the parcel command, and I can show you that in the next video where we start doing the curve number calculations and develop the discharge rates. I like parcels because it'll clearly identify if you don't have closed basins. Well guys, that's all I have for today. We have now concluded episode 2. If you found this video helpful, please hit the like and subscribe button and tune in for more. If you're a younger engineer, feel free to ask questions in the comments. I will always be open to answering your questions that you have. Appreciate everyone tuning in, and I will see you in the next video. Thank you.